we'll go over the calendar, make sure you know what's coming up and when things are coming up. Second, some review activities going over the things that we've done over the past couple of days. Third, introduction of new topic for today. We'll get into our introduction to stoichiometry. We'll talk about that more when we get there. But first, calendar. So if you're watching at home, you don't get the zoom in effect, but you guys, that's the benefit of being here, you get the zoom in effect. Right? So, as far as this week goes, right? Monday we didn't have school. Tuesday we introduced the idea of polyatomic ions and what they were. Then on Wednesday, we started talking about formulas. Started talking about how do we make a formula that contains a polyatomic ion, how do we name that formula, etc., etc. Yesterday, we started doing conversions between mass moles and particles, but now for compounds as opposed to just for elements like we had done previously. I did record class yesterday, and I posted some of the slides that we did in class, so if you have to go back and take a look at some things, there they are for you. Okay? Today, little review activity dealing with formulas, name, balancing, stuff like that. Then we'll get into stoichiometry, quantitative relationships, and chemical reactions. That is our plan for today. Okay? Next week, once again, no school on Monday. Tuesday, first quiz for this semester, dealing with polyatomic ions, names, formulas, and doing some calculations to convert grams to moles and stuff like that. Okay? I'll tell you during class today where like the cutoff for the quiz is. But that quiz is open note. All right? You can use any of the stuff that we did as far as this week is concerned. Also, I will give you the polyatomic ion formulas, and I will give you the charges, so you don't have to memorize those. They'll be there on the quiz for you. That's Tuesday. Then, after we finish the quiz, we'll get back into the stoichiometry thing. We'll talk about, we'll change the stoichiometry problem just a little bit, make it a little bit more complex. Then, on Thursday, for you guys, we'll be back on the stoichiometry, changing it one more time, making it a little bit more complex. Then we will be back on lab. Then we'll be back on lab for the last part of the block period next week, talking about introducing two new concepts, limiting reactant and percent yield. On Friday, we will definitely do some post-lab follow-up stuff, but also on Friday you will have your next quiz over the stoichiometry calculations that we started today, continued Tuesday, continued Thursday. Then we are looking at test 2 weeks from today, Friday, February 1st. Okay? Good there? Question. We'll see how you do today. So. Yes, Katie, go ahead.
Can you go up to today's date?
Yep.
Thank you.
So for tonight, a couple of pages to read from your book, and then a couple of simple problems based off of the stuff, not that we're going to do at the beginning of class today, but the stuff we're going to do towards the end of class today. Okay?
Should I take home my book?
Probably a good idea. All right, we good? All right. To review some of the stuff we've done over the past couple of days, I will start you with this. In a space station, carbon dioxide exhaled by astronauts can be removed by a reaction with lithium hydroxide. This reaction produces lithium carbonate and liquid water, which obviously can then be used for other productive purposes on the space station. In words, that little paragraph describes a chemical reaction. What I would like you guys to do in your small little 2 or 3 person groups is come up with a balanced equation that represents that chemical reaction. Okay? A balanced equation that represents that chemical reaction. Let's see if we can get this done in about 2 minutes. Ready? Go.
So, I want to know how to do this. Elise?
Oh, as far as writing this down, the sheet that I gave you today, the problem set that I gave you today, the whole back is blank. So, you can do it there if you want to. This isn't a turn-in thing, just something to review for us, for the things we've done over the past couple of days. Okay? So, a balanced chemical equation for that reaction. Go.
Wait, Mara, what do we do? Hydro, what's that? Will people tell us all the answers? How many is hydro? How many is hydro?
Hydroxide is one of those polyatomic
Yeah, how
ions.
many is? No, that's hydrogen.
So you said you had the grid from Tuesday, right?
Yeah.
Where's that grid that we were looking at in class on Tuesday?
Ah, there it is. We didn't talk about how to use it.
So that's, we did that.
Oh, well, I was under.
Nicole has it filled in though. She might be able to help you.
Hey, Nicole, you're the best. I love you so much. You're a great person. I really appreciate your hard work in this lesson. I use that. Oof, that's a lot of stuff I need to write down. Is there anything else I need to write down? Did I miss?
That's a lot though.
I put water to save it.
No. But
Yes.
you don't have to
Yeah.
guess what the
No, I've got no more.
it already
I
told
have
you.
no more. That's why I use a copy.
From that description, you should be able to tell what the reactants and the products are. Okay.
Can you grab me a couple? Paper cups are always good.
So, you guys don't have to guess what the reaction is. That description tells you what the reactant is.
Oh my gosh, I really I do.
No, I know.
It tells you what you start with, and it tells you what you end up with.
I'm around the best of times, but it's true. Yeah.
Sarcastic.
It's the part I don't know how to do.
You have it written correct.
It's like algebra, though.
I don't know if it's balanced yet.
I don't know how to balance equations. Yes, you do. Oh my god. Oh.
This isn't lithium carbonate, that's just carbonate.
Mr.
We got right so far. Plus
Yeah, you're good. Tell Elise how to do it.
boom.
That's
Can I
right.
do it? Does
You-
it balance it though?
It's not balanced yet, but
Wait, is it like this? And then you do carbon
Well, I got-
dioxide?
Yep.
Yeah. Right besides balancing it.
I just forgot the LI.
you should really define carbonate.
Now it's balanced.
But I said CO2.
Yes, that is the right
That's
answer.
lithium carbonate.
Yes.
That's,
Yeah.
what else does it, what does it tell you is produced in this reaction?
Is this?
Oh, now it's a liquid water.
No, it's not yet. Closer. What else is produced in this reaction? What does it tell you is produced? It's part of the water.
What?
This is right.
Wait, I don't want to see the balance yet.
So, Mr. Payne, did we find any
That's
notes?
still not lithium carbonate. No, we've pretty much been doing polymers.
Oh, brilliant.
Have you?
That makes it really hard for me to
You need to have
sides of that equation, right? Mass. Right now, you don't have two sides of that equation. Well, what goes on the other side? What do we call the other side of that equation? The products. Does it tell you what the products of that reaction are?
Tracing your name.
Carbonate.
So you gotta come up
I just had to finish the okay. We're good.
You might need your grid back to find carbonate from back up.
Sorry, bud. I don't know. Dude, you just put a Ah! Sorry.
Find carbonate.
Someone yelled? No. You're hearing things. As long as no one yells. Right?
Actually, that right there will help you, right? Make sure you got the formula right, but what's the charge on that?
ADHD acting up and about.
Formula that informs you. That's going to affect the compound that it forms with lithium. Because really, what's the charge on the lithium?
Yeah?
What's the charge on the lithium? Where's lithium on the periodic table? So it's plus one charge.
The dark ones are supposed to be active balance.
Oh.
Balance with coefficient subscripts, right? So, does Joe remember how to balance equations?
Hey, in a second, I just put you
Dude, you can throw a coefficient right in the middle of a formula.
I know, I'm so confused.
Formula for lithium carbonate.
And what?
What's the charge on carbonate?
Mr. P, what is your opinion on this equation?
I'd be in favor of that equation. I'd vote for it. If it was running for office.
So
I don't know
confused.
what it is. I just read that.
I know, but then there's like 8, 15. Well, not 15. There's 7 there though. It says 6, 7, and then 4, 5. Now am I done?
Sure there's 7.
This side? Yeah, you said 6. 7.
But it looks like there's a coefficient in front of that, isn't there?
It says 8. Am I done? 8.
Except, yes. Except
Oh,
for the fact
that's
that
right.
what goes in between the two sides of an equation.
Because you have to.
It's an arrow.
We'll sign this one.
You still tell them to put a coefficient in front of the oxygen. You can only put in front of the H to account for the
You don't need to do that.
I have that.
Okay. No. Not done.
Oh, I don't know how to do this. No, I'm not going to balance it.
All right, so first, to make some connections to what we're going to do later on in class today, what does a chemical equation do for us? Why do we write chemical equations? What does a chemical equation do for us? All right, go ahead.
tells us the type of the elements that react and
How about instead of elements, it tells us the type of substances that react, and what else does it tell us?
how much.
Doesn't tell us how much. It tells us what is reacting, but what else does it tell us?
What happened?
What happened or what is produced, right? So it's just telling us what's going on, right? All right, is this balanced as written? No, right? There we go. Okay? Good with that?
Fantastic.
All right, your next bit of review activity. Every day, on average, a person will exhale
This is cool.
20 moles of carbon dioxide. On average, a person will exhale 20 moles of carbon dioxide. But how much is 20 moles of carbon dioxide? Most of you probably have no idea. So, why don't we figure out how many grams of carbon dioxide that is? Okay? small groups, go.
And so by the time we're like, I don't know.
What? Do your units. Set your units up in your conversion factor.
And then there's a thing of carbon dioxide. We did this thing. We find the formula mass for of carbon dioxide. So carbon is 12 grams.
Where do we get the number that goes in front of grams? Except it's not called the formula mass. Right?
You just add them together.
Okay, so you start off with 20 moles of carbon dioxide.
44. Oh, no.
Sorry, 20 moles of carbon dioxide, right?
Wait, where do you put the, Mr. Clayton said?
That's correct.
I don't think it's right. It's too many. Coach P, if you have 20 over 1, then where do you put the, that's not right.
Thing you calculated.
Really?
It's not done signigs. Well, do your units first. Where is moles going to go in that conversion factor? Okay, because why?
Cancel out.
Trying to get rid of it. What are you trying to go to?
Wait, is this 880 then?
Oops, sorry.
Grams.
Yeah.
So,
So here, what unit has to go on top of this conversion factor? So where do you get your grams number from?
That.
Formula mass. Where do you get formula mass from?
then add it up. And then,
Is that grams?
is it over 1?
Yeah.
What unit goes on the bottom of that conversion factor? What unit goes on the bottom of that conversion factor? Moles. What number goes in front of moles?
Did you get 880?
Always.
Yeah, and then you
What
only do
number goes in
880.
front of moles? What number goes in front of moles?
And so the zero's not significant. Just old.
No, it's like 1, 2, 3 there.
Like, it's saying how many moles it lived in hydroxide.
Mr. Clayton said you
So what units go on the bottom of that conversion factor?
You don't need to know.
Moles.
You just need to cancel the unit.
So like you put moles there over 1, and then
880.
Same way you would convert inches to feet.
What number goes in front of moles?
Don't worry about
do you have a second?
Or we said it's formula units, right? Depending on what you're talking about.
8.80 times 10 to the power of
Oh yeah, that's what I have.
Alright, so in doing this conversion factor, right?
Just joking.
Compound, you just add all the atomic masses of all the elements in that, or all the atoms in that.
Is there any dividing or anything?
I forgot he was about it.
Alright, so for this conversion factor, right? So, conversion factor, we start off with the bad number, right? The number we don't want anymore, the 20 moles, okay? 20 moles. If you want to put it over 1, great, that's fine. You're just turning it into a fraction, okay? Time sign fraction bar. Moles has to go on the bottom of that conversion factor, so we're trying to cancel it. Grams has to go on the top of that conversion factor because that's the unit that we're looking for in this problem, right? What number always, always, always goes in front of moles? 1. Always, always, always goes in front of moles. What number goes in front of grams? Okay, go ahead.
The formula mass,
The-
which is 44.0.
The formula mass, which in this case is 44.01, right? Katie, how do you get the formula mass for this compound specifically?
You add.
Oh, sorry. Katie, go ahead. How do you get the? Yeah, she was answering too. Yeah, I know. I really did. Now, at least you guys aren't sitting directly next to each other anymore, like you used to. But right, we'll go with this, Katie. Okay. So, Katie, how do we get this formula mass for this compound specifically?
You add the atomic mass of carbon and then 2 of oxygen.
Yeah, you add the atomic mass of carbon plus 2 average atomic masses of oxygen, because in this formula, right, 1 carbon, 2 oxygens. Then, we just do our math, right? Moles of carbon dioxide in the numerator, moles of carbon dioxide in the denominator, they cancel. You run that through your calculator, you end up with 880.2. Is that your final answer?
No.
No. How many sig digs does that number need?
3.
3, right? So you got 2 options. You can go like this, okay? Or what's your other option? Scientific notation is your other option.
Do you have to have the decimal?
Okay?
Do you have to have the decimal?
You
Yes.
have to put the decimal there, right? Because if you don't put the decimal there, is that zero? The zero isn't significant, right? So you got to have the decimal, but you can't have anything after the decimal, because if you put anything after the decimal, that takes you up to 4 significant digits.
Only thing I understand all class. What? Nice one.
All right.
Thanks.
Are we good there?
Easy.
This is pretty much your quiz on Monday or Tuesday, right? You won't have to write the equation, but if I say, hey, a reaction contains lithium hydroxide, what's the formula for lithium hydroxide? You're going to have to come up with this, right? Or if I say the product of a reaction is lithium carbonate, what's the formula for lithium carbonate? You got to come up with that. You won't have to come up with the whole reaction, but you will have to come up with parts. Specifically parts that contain polyatomic ions. Okay? Then you're going to have to calculate formula mass, and then you're going to have to do a conversion. Okay? Good there? That's your quiz Monday, Tuesday. All right. From this point forward, this will not be on your quiz on Tuesday, but this is where we are going next, and why we started this week with these things. And that next subject is stoichiometry. Alright, so today I gave you 2 new sheets. One of those sheets was an outline. That's where we're going to start stoichiometry. Alright. Before, when I had you write that chemical equation, I asked you, why do we write chemical equations? What's the purpose of writing a chemical equation? And what did we come up with? Why do we write chemical equations? Or what does a chemical equation tell us?
It tells you the products that you get from a chemical reaction.
It tells you the products, but it also tells you the reactants. So it tells you what is reacting. But it doesn't tell you how much is reacting. That's where stoichiometry comes in. So, first thing on your outline, right? Your definition of stoichiometry. Mass and quantity relationships among reactants and products in a chemical reaction. Stoichiometry is a quantitative process. It tells you quantities. It tells you numbers. Whereas equations are qualitative. They just tell you what is reacting, but not how much. Stoichiometry tells you how much. Stoichiometry is the calculation of quantities of substances involved in chemical reactions. Calculation of quantities. So again, that word shows up. Quantities. We're dealing with measurements and numbers and calculations based off of those measurements. Big important part of stoichiometry problems comes from a chemical equation, specifically a balanced chemical equation, and more specifically, the coefficients of a balanced chemical equation. So balanced chemical equations, specifically their coefficients, are going to be very important in comparing one part of the equation to another part of the equation. Go ahead, Farah.
Don't the coefficients just tell us how many molecules there are?
Yes, and that's important. Okay, that's important to calculate, and I'll show you how that works in just a second. Okay. All right. So let's do this. Farah, this is good. Okay. All right. Here is a chemical equation. First, what kind of a reaction is that? Ready? That's a synthesis reaction, right? We're taking two small molecules and making something a little bit more complex. Okay? But two things are wrong with this. Well, there's one thing that's obviously wrong, right? What's obviously wrong about this chemical equation? It's not balanced. Okay? So, you throw these coefficients in here and you get balance. Okay? Last period, somebody got this analogy and it took me to where describing it this way. Okay? This equation, unbalanced, is like a list of ingredients in a recipe. It's like saying, okay, to make chocolate chip cookies, you need brown sugar, flour, chocolate chips, and whatever else is in chocolate chip cookies, eggs, and whatever. I don't know, okay? But what's missing from this?
The amounts
The amounts that you need to make what you gotta make, right? I know that I need nitrogen and hydrogen to make this NH3, but do I know what ratio to join them together in to get what I need to get to? Not yet. Not until I do that. Okay? So now this is telling me that I need 1 molecule of N2 plus 3 molecules of H2, and I will get 2 molecules of NH3. Does that make sense as far as what the coefficients are telling me here? Okay? Now, can I see 1 molecule of N2 reacting with 3 molecules of H2 to give me 2 molecules of NH3? Can I observe that happening? No. Why not? Way too small. But let's say I had 1,000,000 molecules of N2. If I had 1,000,000 molecules of N2, how many molecules of H2 would I need? 3 million. And I'd get 2 million of these. Still wouldn't be able to see it, still way too small. But that's how the coefficients are giving us the ratios between the different parts. Does that make sense? Okay, we good there? All right, let's use that knowledge to now tell us something quantitative about this chemical equation. Let's skip this here. Okay, we are going to start with mole-to-mole calculations because they're the easiest ones. We're going to branch out from there. Okay? Moles to moles compares the moles of one part of the reaction to the moles of a different part of that reaction. It could be reactants to reactants. It could be reactants to products. It could be products to reactants. We'll see all those different variations as we go along. But there are 3 steps. The first thing we have to do is we have to write a balanced chemical equation. We gotta have a balanced equation first so we get the ratios. After we get the balanced equation, a stoichiometry problem is just a conversion problem. And we've done lots of conversion problems. The same principles will apply. We just have to make sure we fill in the right numbers. And we'll talk about those in a second. We start off with the moles of whatever we gave or what they gave to us. And then we set up conversion factors to get the moles of whatever we're looking for. Okay? For example, letter C underneath Roman numeral number 2 is this. Oh, look. Convenient. You did this already, right? Yeah. So, somebody was thinking around here. So,
Wasn't me.
I'm not saying who, just. All right, so here's our first stoichiometry problem. Let's shrink this down a little bit so we got some room to write. Okay, it says, in a space station, carbon dioxide exhaled by astronauts can be removed by a reaction with lithium hydroxide. This reaction produces lithium carbonate in liquid water. Okay, so here's problem number 1. It says, how many moles of lithium hydroxide would be needed to remove 20 moles of CO2, which is the average daily amount exhaled by a human? First thing we need to do in doing stoichiometry problems is what? What does it say step number 1 is? Balanced equation. Luckily for you guys, we did that already, right? We said there was 2 reactants to this reaction, right? Lithium hydroxide and carbon dioxide. And those 2 reactants gave us lithium carbonate and water. And that when we did that, you needed to put the coefficient 2 out in front of the lithium hydroxide to balance it out. Good? Okay. Now, let's get down to the business at hand, right? How many moles of lithium hydroxide would be needed to remove 20 moles of carbon dioxide? Okay. All right. So as far as this problem goes, what did they give us to start with? What number, what measurement did they give us to start with? 20 moles of what? CO2. What is this problem asking you to figure out? Of what, Maddie? Not carbon dioxide. Okay. That's what this problem is asking us for, right? If I'm exhaling 20 moles of carbon dioxide, right, how many moles of lithium hydroxide do I need to react with that, to get rid of it? Because if I don't get rid of it on the space station, pretty soon my space station fills up with carbon dioxide, and that's a problem. All right? Good there? Okay. Like I said before, stoichiometry problems are conversion problems. No difference in the process. Obviously, the numbers are going to be a little different, but no difference in the process. So, what are we going to start this conversion problem with? 20 moles of carbon dioxide. Okay, what's next? Time sign fraction bar, right? Okay. Now, in our conversion factor, I always tell you guys when we're doing this, right? Start with the units. That's how we're going to get what we need to get here. Okay? What unit has to go on the bottom of this conversion factor?
Moles of CO2.
Okay, moles of CO2 has to go on the bottom, because that's what we're trying to get rid of. What has to go on the top? Moles of lithium hydroxide have to go on the top, because that's what this question is asking us for. Right? Does that make sense?
Yeah.
Okay, now, 2 things before we move on. First, I know a lot of times when you guys are going like calculations from moles to grams and stuff like that, you just sort of drop the formula. It's really important that you keep the chemical formula with this, because you see here, we have a conversion factor that has moles on the top and moles on the bottom. If you don't keep the formulas with them, you're going to get confused. Okay? But let's talk about this conversion factor. Right? We've never had a conversion factor before that has a different formula on the top than it does on the bottom. That's okay. Now we have a way to handle it. What did we say was going to show us the relationship or the ratio between the different parts of that chemical equation? Please?
Coefficients.
The coefficients will show you the relationship between the different parts. So we go back up to our formula, right? What do we see in front of lithium hydroxide, coefficient-wise? 2. So 2 goes on the top of this conversion factor. What's coefficient in front of CO2? 1. It's not written, but we understand that it's there. This conversion factor that shows the relationship between the moles of one thing and the moles of something else, we call the mole ratio. Pretty inventive name, huh? That specific conversion factor that goes one part of the equation to another part of the equation, we call the mole ratio. It's a really important step in every stoichiometry problem. It's the way that we can compare one part of the equation to another part of the equation. In this case, we are comparing one reactant to another reactant. But, depending on what the question asks you for, you could compare reactants to products, or products to reactants, or whatever, as long as you know the coefficients. Good? Okay. So, one good thing about mole-to-mole problems is that generally the math is pretty easy, right? If you want, you can put that over 1, okay? Then, moles of CO2 in the numerator, moles of CO2 in the denominator, they cancel. You run that through your calculator, and what do you find out? Not 40 moles. No, it's not the same thing.
Ooh, burp by Mr. Class said.
So that's how many moles of lithium hydroxide I need each day to get rid of all the carbon dioxide that I'm breathing out. Does that make sense? Okay. Kitty, go ahead.
Wouldn't it just be 40 because 2 is only 1?
Remember, conversion factors are not measurements, right? We didn't measure 2 moles to 1 mole. Those are just given numbers, okay? So when you're doing conversions, it always goes back to what you started with, right? That's still our measurement, whereas that mole ratio, those aren't really measurements, those are just numbers that we know, okay? All right. Is that good for a first example? Okay. All right. The other sheet, not that sheet. My video is going so smoothly until this point. This sheet that I gave you today, Intro to Stoichiometry Problems, mole-mole relationships. Those are exactly the same kind of problems that we just did. Hold on a second. Still trying to record here, and you guys putting papers away. It makes it hard, and that doesn't help either. And there's still 3 minutes left until the bell.
2.
3.
It's not 2, though.
Okay,
Now
go.
it's 2. I'll let you know.
So,
It's almost 2.
over 2 minutes left until the bell. 2 minutes left until the bell. So, here, I have given you the equations. You have to balance them, though. They're not balanced. And then, just based on what we started with, do a mole ratio, get to what we end up with. On the calendar, there's a couple problems from the book, but also that sheet. Answers to the sheet are posted online, so you can check it out. Again, reminder, no mole ratio stoichiometry stuff on the quiz, just dealing with formulas and polyatomic ions. All right? Have a great weekend, everybody. I'll see you on Tuesday.
Open notes.
Yes.
Happy Martin Luther Day.